My name is Shapiro.
David Baker.
We both work at Google on the Java core libraries team and spend most of our time working on Dagger 2. So here's our quick overview. Our goal tonight is to go through what code Dagger 2 actually generates and why you should care. Why is it important? We don't want you to just run Dagger 2 and pretend that everything just works. We want you to sort of understand what's going on. You don't have to understand every detail, but think that there is value in you reading the generated code. Then from that, how you can cut out the waste, take away, optimize your generated code, and also learn how you can suggest better features for us. And then we'll go over some recent and upcoming features and more questions. So here's a quick dependency injection crash course. Does anyone not use any DI framework? No. Okay, great. So we'll go through a quick introduction to what DI is. And we think that actually understanding Dagger's generated code can help you out in understanding DI even better. So first we have at top, and I'll mention now that a lot of our code snippets have things left out for clarity in the slides, but if you have any questions, definitely ask. So we have a slide presenter class with a display out and slides field. And somehow we need to populate those. So one option, which we've all seen, is that the constructor can initialize them directly. But right now, a lot of us will use USB-C. I think right now, this monitor is actually using Thunderbolt. So we want some way to configure this, and maybe we don't always want the same slides. So we can introduce a display factory and a slides factory. But if you want to write all of these, go have fun. I definitely don't. I don't think David does either. Do you?
I don't. And also, the problem with this is that if some other configuration wants to use something other than USB-C, you're still out of luck in that example.
Yeah. So at the bottom is, for people that have used DI, totally normal. For people that haven't, it's a little bit weird, but it's just a straight up constructor. If you ignore the @inject annotation, it takes both parameters that it needs to the constructor, and we stick on @inject so frameworks like Dagger can sort of understand our intention. So in Dagger, we'll have an @component annotation that you can apply on an interface or abstract class, which sort of acts as your entry point. But this is a straight up Java type. You can use this as any Java type that you would normally use. And from that, we'll generate an implementation that implements that. For most of the slides, we've left off the implements slides component, but pretend that it's there. And then the core point that we want to talk about is this field, the provider of slides presenter. What is that? How does it get created? And so on and so forth. So you can see in the implementation that slide presenter method returns the get, the return of get. So what exactly is that? Let's understand that. So in Dagger, most of the time when you want to supply a dependency of binding, you'll create a module, you'll create a provides method. That provides method can take as parameters any dependencies of the method that you're about to call. And then you return a result. And from that, we're going to generate a factory. Factory is also just provider for our purposes. And so let's go through the different things that correlate between a module provides method and factory. So first we have the module instance, which should actually pass through to the factory. We have any provider instances that are dependencies of that method. And then we actually call that module method directly at runtime. So here's the component implementation once you put it all together. And you'll have lots of providers. I think I have some highlighting here. Yeah. So here's the display out provider that we just saw. It takes in a couple of different, it'll take in the module and another provider. Then we have providers which take other providers here. Okay. So let's talk about how you can compose different components. So one way, the older the older method is if we have one component modules as normal, we can create now another component which declares the first one as dependency. And this will generate two Dagger component implementations, one Dagger app component which parallels to the first, and Dagger report abuse component which correlates to the second. We care mostly for purposes of this slide on the second one. And notice that app component takes in, report abuse component takes in an app component and uses that from then on. It's important to note that this doesn't necessitate using a Dagger app component. You can pass in any app component implementation. As we mentioned beforehand, component, it's just an annotation on an interface. You can use that however you want. You could theoretically implement that in another way. And we're using Java 8 here for conciseness, but you definitely don't have to. We don't have to. We don't output Java 8.
We don't output Java 8 yet. To the degree that we can, we will start to degree of support.
So the way that this works is Dagger report abuse component will scan the methods in an app component and create providers from all of those methods, sort of wrapping those methods in an object. And we'll contrast that in a second. You'll be able to see some differences. But anything in, let's say, base module here, you're not going to get necessarily in report abuse component because it only exports Firebase analytics. So here's another approach. We have the same app component, but the report abuse component is now a subcomponent of that. And if we look at the generated code, here's the major difference, is that the subcomponent is an inner class of the parent component. What this allows is for us to reference this Firebase component from the inner class, and any provider that was in the parent is now also installed effectively in the child. It gives us a lot more flexibility. Great. So let's talk about scopes. So when you provide objects, most of the time you want to give a new instance every time that object is requested. But sometimes you want to specify that whenever you request that object, you want to get that same key. So on the provide side, you can give out a scope. Here we gave singleton, but you can give sort of subscopes, which we won't talk about so much. And then you apply that same scope annotation to the component. And what's this actually do in the generated code? We wrap the provider that we were initially creating in the double check provider, which does all the double checking from effective Java for those that have read, and ensures that no matter what thread you call this on, you're always going to only call that provides method once and exactly once.
Within the lifetime of the component.
Yes, that's very important. All right, so that's the bare bones of the Dagger component application. Let's see how you can apply that knowledge. So this is the first optimization, and I was joking to someone earlier that we don't do a great job of promoting our features because Google will just migrate people automatically. But these are all suggestions that real life things that you can do tonight, tomorrow on your code. So the first thing is a static provides method. So at the top we have that same slides module that we had above and the generate code. But there's nothing in the module that actually needs an instance of that module. It's an instance method now for convenience, but it doesn't have to be. And if we make that static, we now no longer need the slides module instance, but we can call that static method directly. So almost 99% of your provides methods can be static and should be static, and it'll save you a lot of instances when you're creating your component. And that's sort of our biggest complaint so far, is that component creation is just creating lots and lots of very small objects, but lots of them. So this with the exception of when you need maybe to pass an activity instance, a fragment instance, to provide into your modules, you can almost always use a static provides method, and we encourage it. But as we said, we create lots of providers when we create our Dagger components. And this is something that we're working on to make better, and we have some tips of how you can make it better and how we can do it as well.
Basically, as a rule of thumb, for every binding in any module in your component that is actually used, Dagger creates a field that holds the provider for that thing. If you think about the number of bindings in your component, is a lot of fields. And it's a lot of instances that need to be held by the component, and it's a lot of instances that need to be initialized. One of the initialize methods you probably see. And the initialization of these fields happen when you create the component. So for instance, in the root component of your application, all of the fields, all the provider fields in that root component need to be initialized before the component really wakes up and can be used. No, that doesn't mean you're actually creating the foods and the bars and the baskets. You're just initializing the providers, but that's still a fair number of fields and a fair number of objects that need to be initialized before your application can start.
Yeah. And those factory or provider initializations, you're not going to really see that in a profiler except in aggregate or when you initialize your component. So important to if you see the component creation time is taking a while, this is what it's probably doing.
So what? So I said before that all bindings in your component get a provider field. It's not actually true. We already do some things that are somewhat smart. For instance, if the factory class that we showed you before, where every provides method or every inject constructor, it's a factory class, which has to be created. You have to create an instance of that factory in order to assign it to the field. If that provider is, or that binding is either an inject constructor or a static provides method and has no dependencies and has no scope, then that create method that creates that provider can actually just return a private static final instance. So there's actually only one instance of that provider. So even if we had lots of provider fields for that particular provider across your components, they would all get the same instance. And in fact, we just skip that entirely and just call whatever your factory is .create whenever we need it. Which means that is one less field for each of these bindings that is actually created and stored in the component. So that's good. But again, it has to be an inject constructor or a static provides method. So that's yet another reason to prefer static provides method. It also can't have scope. And the reason we can't have scope is the way scoped bindings work is we take the provider for that binding and we wrap it in a decorator provider, which is this double check class, right? Which does it caches the value returned by the provides method and does double check locking to make sure that the only part of the provides method works. So even if the provides method is static and has no dependencies such that there's only one instance of that, you still need an instance of the double check wrapper in your component. So that's why scoping defeats that. So there's another optimization we can do. Right? So here's an example of what I said before. Instead of there being a foo provider, which is initialized to foo factory.create, we just use foo factory.create wherever we need one of these providers. But assuming that foo is just a single class with an inject constructor that has no arguments, we could get even simpler. And we could avoid creating foo factory entirely and just call new foo wherever we need it. So that's something that we are working on. I don't think that we currently do that, but we're
if that's not in Dagger 2.7 or 2.8, I can't remember what we're at, it'll be at 2.8 or 2.9 as soon as I release it. But we're working on some more things, which David will talk about in a second, to make that even more applicable in more cases.
Exactly. So again, this only works if foo is only ever injected as an instance of foo. If anything injects a foo as a provider of foo, then of course we need a provider. And once we need a provider once, we might as well create it once and store it in a field and call get on. So this optimization, which again, you don't have to do anything to trigger, Dagger will do it for you, is only so far applies to a few things. And it gets worse. Well, actually, it gets better. So first it gets better, then it gets worse. So again, imagine you have these 4 well-named classes that where cooks and baths have no arguments to constructors, but bar just takes 2 of those and food takes 1 of those. If that's the case, and we only ever need instances of all of these things, we can inline all of that and get rid of 4 providers. It's nice. But, and here's the bad news, that's defeated if foo or any of these other things is ever injected as a provider. So all the way to your entry points, which are the methods on your component. If anything in the path from one of the entry points to foo is injected as a provider, all of these things have to have provider fees. Because the factories for all those things need providers. And you can't tell that they're only going to be injected in these instances. Now, this is something that is true about the way we generate code today. We are working on some experimental things so that the Dagger generated code can be smarter about that and inline some of these things anyway, but that's not it.
Right. So here are some suggestions of what you can do today to slim down your components. So the first are delegate bindings, and we'll give some examples. So imagine you have a login activity presenter, and then you have an implementation class. It doesn't really matter what they are. So this is how you currently do it in Dagger 1, probably in 2's also, and in Dagger 2 if you're not using one of our newer features. So you have your module, you have your provides method. You're going to return straight up login activity presenter, the interface, and in order to supply that, you request the concrete implementation, and you return that immediately. This is, by definition, boilerplate. It's what everyone's doing. It's simple, but we can do a little bit better. So what you see here is that we've made the module abstract and this binds method abstract, or rather, we switched provides to binds. Now we don't have any body in that method. And this is an indicator to Dagger that you just want to delegate these 2 things. Whenever you request a plain login activity presenter, give me the concrete implementation. And this actually allows us to save a decent amount of code. You'll note that, and you'll see this once we take a look at the generated code, we've made these abstract because there's absolutely no intention to ever call these methods. We use this because it's a way to take advantage of the Java type system compiler, and if you're using qualifiers, it's a great way to use those as well, but we don't have any intention to ever call these methods to instantiate this module.
Or implement. There's no subclass.
So here, we're taking a step back to when we're using provides. So we have the first provider of the concrete implementation, and then we have the interface type. So first we create that concrete implementation, and we pass the interface type factory the implementation. This is 2 fields, 2 that happen to initialize, 2 factories, 2 generated classes.
And the login provider is doing something pretty trivial, right? Its get method just calls get on the other provider.
So if instead we switch to binds, this just becomes a cast. Right now it's still a field. We're working on eliminating that field and just inlining it in general. But this is just a cast, and we can treat them as the same object. There are a lot of instances of this in lots of user code. We found this to be a huge saving. At Google, we recommend everyone take a look at this. It also is a much more declarative API for what you're trying to do. It's less error prone.
Talk about error prone. Speaking of error prone, is anybody familiar with error prone? Did we talk about that already? So error prone is a static analysis tool. It's open source. It's coming out of Google, and it will. One of the things that it can do is apply refactorings to all the code if they're well defined. So we have a number of them. One of them is something that you can go through the entire code base and find all the cases of a provides method that just returns an implementation, just like that, and can generate basically a patch that converts all computers. So we have to document that, but that is out there.
Yeah, we have plans of doing that, but everyone should go home. There's a Gradle plugin to enable error prone. It's essentially a plugin into Java C, and you'll get a lot of other amazing benefits into your compiler, in addition to some Dagger specific ones. You notice here that this is we're casting to raw type. Well, if you're ever inspecting the Dagger generated code, you'll notice that these are safe and covariant casts. We do that a lot if you have inaccessible types. That's sort of, those are the two things to be aware of if you're ever actually inspecting this code, which we definitely recommend you do. Let's talk about scope.
So scopes. Just to review, the primary use of scope, right, is to make sure that an object in your binding graph, an object in your application that absolutely must be shared among other users is actually shared. Right? Everybody gets the same instance of the event bus or the singleton thing, whether that's singleton or another scope. That's the main reason to use scoping. Dagger implements that by, as I mentioned, wrapping the provider in a decorator that uses double-check locking, and so it comes at a cost. It comes at a cost because there are certain things that Dagger can't inline. It comes at a cost because there's more to initialize at the start of your application. It comes at a cost because actually implementing the double-check locking comes at a cost. So use it when it's necessary, but the message of the next couple slides is don't use it when it's not necessary. So here is an example, or pretty much the primary example of the code. And we see this a lot. People use scope to scope for documentation purposes, things that don't need to be scoped. So example, activity module, or any other module where you have some instance field that you're providing via provides method. This is something you can't make static because it's referring to an instance field. That's fine. This is all good. But notice, a lot of people do this. They put activity scope on top of that because, of course, it is logically, there's only one per activity because it's an activity. And so it seems to make sense from a documentation perspective to do that. But the problem is, if you do that, Dagger doesn't know that you're only doing it for documentation purposes and can't tell that the object return from that method is always going to be the same. So it still wraps that provider in a double-check locking provider, and you still pay the cost for the extra provider instance, the extra fields in that provider instance, the extra locking that are useless. Because even if you call, because again, all it's doing is making sure that you never call provide activity more than once in that component. And it doesn't matter if you do. So the advice here is use scope when you need it, but as an example, don't use scope here. If you just changed it to this, your application would be exactly as correct. It would just be faster and smaller. Another reason that people use scope, other than logical correctness, is because in certain environments, like Android, it's useful to minimize the number of things you instantiate. Right? You want to call new as little as you can, because it's expensive. So there are some objects that don't have to be shared, but they don't have to be separate either. Immutable things, as an example, right? Where you don't really care if every injector of this thing gets a different one, but if they share it, it works, nothing's wrong, and given that, you'd like to call new as few times as possible. So often what we've seen people do is they throw a scope on it. Often that scope is going to be singleton because there's no real reason it has to be in a particular component. You don't know where it's used. It might only be used in a subcomponent or a grandchild component or something like that, but since you don't want to make a decision and Dagger scopes force you to decide exactly the lifetime of your object, you make a decision and you put it at the root and put it safe. But the problem with that is that now you are paying the cost of that binding and all of the bindings that it itself injects, everything it depends on, have to move into the singleton component. And you pay the cost of initializing that singleton, even if it is never used in the singleton So we introduced a new scope called reusable. Oop, I'm going to show you an example. So before I show you about reusable, so here's an example, right? You have a useful thing, you've decided to make it singleton because you don't want to instantiate it too many times. You have a parent interface that doesn't use it. It has two child subcomponents that both use that useful thing. What ends up happening when you generate code is, right, you have that Dagger parent, and the useful thing provider is all the way up there at that root component, even though it's never used. Okay, so we introduced a new scope called reusable. It basically is a signal to Dagger that for this binding, this object, it's okay to share instances, but it's not necessary. So do something reasonable based on it. You don't associate that scope with any one component. Normal scopes in Dagger, you actually have to indicate which component in your component hierarchy identifies the lifetime of that scope. Reusable, you don't and you can't do that. And the way we implement reusable right now is we actually put the provider into only those components that actually use that binding, wherever they are in the tree, below where you install. So you can install that reusable binding in your root, and if your root component doesn't use it, it won't get it. So the TLDR here is if you're ever using scopes just because you don't want to allocate, not because it has to be associated with this lifetime, try using reusable and see if your generating code gets smaller. And the way you'll notice it is this is what it used to look like with singleton, where you have that useful thing provider in the root component. And if you change that to reusable, and both of those children use it, now they each get a provider, which of course has to be instantiated, but only when that component is used. So your root component and a subcomponent that doesn't use that thing don't have to pay the cost of initialization.
So we're really interested on usage of this. So if you use it and you inspect your generated code, you see that things are moving further down away from your singleton component, let us know because we're curious to see if this is something that people are getting value out of.
Let us know if it's not useful to you.
Awesome. So here's a very new API that probably aren't aware of. I'm going to do. So let's talk about subcomponents a little bit more. So here we have our app component, and like many activities in Android, we have a subcomponent specifically for that activity. So here we have debug settings subcomponent builder, which we'll use when we need to create that activity. So here's subcomponent, and here's the generated top level component. As you'll notice, there's something singleton in the top level component. Sorry that our naming isn't the best. So if we're going to sort of switch around the implementation and see what we can do, the main point here is that even though something singleton is used in debug settings, if we need one instance per lifetime of the application, but it's only used in a subcomponent. So if we were to put that in the subcomponent implementation, each time you create a new debug settings subcomponent impl, you would get a new instance. We don't want that.
And the other thing to note here is that if your application never actually calls debug settings component to instantiate that subcomponent, it doesn't matter. You still pay the cost of initializing it. You still have the nested class in it, Dagger can't.
A good example of this is if you have your debug settings and you don't remove in your production version of your app, you maybe remove that activity from your manifest, remove all the hooks that you would get into the activity, but you never actually remove the code. That code is still in your binary. You pay the cost of this, raising your APK size and raising your app initialization time. So what can we do to make this faster and less wasteful? So we introduced a new API called module subcomponents, which allows you to, instead of tying a subcomponent to a parent component via a method, that once you add it to a method, we can't ever tell if you're going to call that or if you're not going to call that. But once we have something that's not executable, we can tell if you ever inject it directly.
So just to show you what's specifically in this API, you notice that app component doesn't have any subcomponent method for the debug settings subcomponent. And instead, at least in the debug app component, it still has no subcomponent methods. It installs a module, debug settings subcomponent module, which has a subcomponents, a new subcomponents parameter to it, which effectively says that that module provides a builder for that subcomponent. So there is now, because you installed that module, there is a binding for debug settings subcomponent.builder, which you can now use instead of calling a method on the component. If you need that subcomponent, you just inject that builder.
And so in our production version, we never need to create, we don't have a subcomponent method, we don't have the module, it's never referenced, we don't need it. And in debug app component, we only generate that subcomponent implementation if you request it. If you never request it, it never gets generated. And on top of that, that singleton thing, or something singleton that we included in a previous slide, if you never request, next slide. If you never if we never generate the subcomponent, we don't even need to generate the provider in the parent component. That can be a pretty big savings. And stay tuned, we don't have slides on this now. We have some exciting Android features based on top of this that will hopefully come out soon. So now let's take a look at some other recent features and things to look forward to in the future.
Okay. So sometimes you have a class that needs to work whether or not some optional feature is available in that particular build. So effectively, the class needs to inject something if it's available, and if it's not available, you don't want it to be available. You need to inject optional. Here's the example, right? You have a drawer controller, and if your build includes a tablet, some tablet UI helper, you want to use it when you draw your UI. So you would inject, the simplest thing to do is to inject an optional of your tablet-only UI class, and check to see if it's present, and if it's present. But the question is, how do you get a binding for that option? How do you get it in a way where you can now contribute this class to a component that provides the tablet UI and a component that doesn't provide the tablet UI and not have to change this class? So again, I have two components here, one that doesn't have the tablet-only UI and another one that does have the tablet-only UI. I still want my drawer controller, and I don't want to have to think about it. Many people ask me. So there's a hacky way to do it that involves multi-bindings, and you already know about it. So the new feature is called binds optional of or optional line. So again, in one of these abstract modules, you annotate an abstract method with binds optional of, and you give it the type you want an optional binding for. You now have a binding for optional of tablet-only UI. Both Java Util optional and Guava's common base optional work, and you get a binding for optional tablet-only UI and optional provider of tablet-only UI and all of those other things. And the way it works is, if a component has a binding for tablet-only UI, the optional that you get is present, and its value is whatever the provider would have normally given you if you just injected that thing. If the component has no binding for tablet-only UI, you get an absent optional. And it even works with subcomponents. If a parent component has no binding for tablet-only UI, but a subcomponent does, then bindings in the subcomponent can see it, and bindings in the parent component can't. And unlike the multi-binding hack that I didn't really describe, there's an error if there's more than one binding for a tablet-only UI. It really does restrict it to either 0 or 1.
I'm kind of surprised we didn't include too much on multi-bindings, now that I think about it. But it's important to mention now that similar to how here on the last line, if you have a parent which doesn't have access and a child that does, for multi-bindings, I should include in the slides afterwards. For example, if you have typically a binding in a parent and a child, that'll conflict in the child. That's an error. if you have a multi-binding, let's say a set of numbers in a parent, and then you contribute more contributions into the child, when you request that set in the child, you'll get the set of all those. That's something you should
get all the elements from the child everywhere. But we don't have slides for that, so we can just say. All right, here's another feature that we have yet to release. Memory-sensitive scopes. So again, scope bindings mean that the binding is wrapped in a double-check locking provider that caches the value, stores it in the field. And it retains that starting from when it's first injected or requested, and it's kept until the component is destroyed, which for the singleton component is the entire lifetime of the application. But sometimes you have scoped bindings that, again, are scoped, they're heavyweight, they take up a lot of memory, and they're not used continuously. They may be used at the beginning, and then sort of thrown away, and maybe used again later. And you may have a low memory event in the meantime. But you're out of luck because Dagger is going to hold on to that reference for the entire lifetime of the component. So, here's what you can do. You can define a scope and annotate your scope with these references at. And you can give it one of the constants from component callbacks to, that's really good, which, if you're not familiar with that, it's probably not very interesting. And what that means is, if you have a binding like some bitmap, as an example, is some bitmap you don't want to instantiate lots of times because it's big, and you just want to keep it once while you're using it and then throw it away, you can annotate it with that scope, and then if in your application, the pattern is you inject one of these Android memory-sensitive reference managers and delegate to it in your on-prem memory, what will happen is that all of the bindings whose root references at value are at or above that level, those providers, instead of will switch from using a regular old reference to using a weak reference, which means that on the next time garbage collection runs, hopefully, if nothing else is using that bitmap or that reference, it will be garbage collected. If that happens, and you then need it again, you'll go through the process of calling the provides method or whatever it is that gets that thing. So you'll still have one, it's not gone forever. And of course, if it is still used when that garbage collection happens while it is in weak mode, it won't be collected because there is some reference to it, which is how weak references work. So again, it kind of relaxes the constraint of scopes, which guarantees that there is only one, there's exactly one instance of this object. And with these memory-sensitive or reference-releasing scopes, it guarantees that there is only one instance of that object at any one time. So there may be an instance, and then it goes away, and then another instance again, even within the lifetime of the component, which can be useful for certain things.
We have some plans to add some testing infrastructure to make sure that you're not, let's say you're using Android memory sensitive, but then you're also retaining a strong reference somewhere and you're calling release and you think everything's being released, but it's actually being retained. We have some plans to add some test infrastructure to make sure that when you're using this, it's working as intended.
And then I think the last thing that we're going to talk about is very experimental. We're not really releasing it yet, but we're working towards it. It is an SPI. And the basic idea is, if you look at the generated code, you're not actually seeing the binding graph. You're seeing generated code that's intended to be done. And it's useful to look at, but it's not really the binding graph. And there is such a thing that we are aware of as we're actually looking through all modules and all components and looking at bindings and dependencies. So it might be useful for you to look at that binding graph and do things with it. So we're gonna release an SPI to be part of that. You'll be able to basically write a class that will be handed the binding graph in some form, probably using Guava's new common graph graph types, but we're not sure yet. After Dagger has validated it, but before Dagger generates the component. You can do whatever you want with that, except change it. So some ideas are to perform project-specific validation. You can have a perfectly valid Dagger binding graph that's perfectly fine, but you and your project have decided that this particular class can never be used in that component, or this particular class can never depend even transitively on that particular class. You'll be able to do that kind of analysis and actually report errors that will break people's build for your component. Dagger will not generate a component, and if you do it, if everything goes right, people will see the little red squiggly line saying, I'm sorry, you're not allowed to do that with this project. You can analyze the graph. Who knows what you can do with that? You can make suggestions for how to change bindings or how to move bindings. Again, you won't be able to actually change bindings, but you can certainly report and again. So as a silly example, I don't know if anybody's looked at the functional tests for Dagger, but we have some silly example components. And I ran a version of this and used GraphViz to provide to draw a graph of the binding graph. And don't bother zooming in, it's not that interesting. But each color is a different component or subcomponent in this component tree. And so each box is a different binding within one of those components, and the arrows show dependency requests between bindings. And the ones on the left with the bold outlines are entry points into each of those components. And you can even see dependencies that go from child components to parent components, or to grandparent components. Again, I don't think for anything other than a toy graph, a simple thing like the binding graph is going to be useful, but it gives you an example of some of the things. It hopefully inspires you to think of other things you might do with it. So look for that to come out in the next release.
And if for the more visual types out in the crowd, we're definitely looking for ways to help people make sense of their Dagger graphs. It's definitely something that's really hard, especially as your application grows. So if you find a really cool visualization, if you need help doing that, we'd love to collaborate on that, or to maybe have a contrib package to be able to include that. It's definitely a useful feature for everyone.
Absolutely. You'll be able to release some SPI plugins for Dagger and have other people use them if that's a useful thing. Again, we don't have any real specific ideas about that yet, other than that very general stuff. So definitely let us know if you have any cool ideas for how to use this. And yes, this is an open graph. So we can cover that. So.
Any questions? All right. Well, definitely feel free to come up to us afterwards. The next slide has our emails and links to our GitHub and code and docs. Definitely file issues, ask questions, reach out to us directly, let us know how we can help you. Great. Thanks so much, and have a great day.